Okay, let's continue on in this video with two more accounting problems. These two problems, 15 and 16 from Sheldon Ross's A First Course in Probability, edition 8. And as always, I encourage you to work through these problems on your own first and then come back and check through my examples afterwards. Let's get started. So number 15, a dance class consists of 22 students, of which 10 are women and 12 are men. If 5 men and 5 women are to be chosen and then paired off, how many results are possible? Well, we have some steps to complete here. So step 1 is going to be to choose the 5 women and the 5 men. So once we've done that, we then will go, and so the next step will be to split the chosen into pairs. And the way we're going to do that is going to impose an order on them that we don't want. So our last step is going to be to divide out the overcount. And we'll talk through that when we get there. Okay, so step 1, we're going to choose the 5 women and the 5 men. So from the 10 women, we're going to choose 5, and from the 12 men, we're going to choose 5. So basically we have now, and we can even order them, woman 1, woman 2, 3, 4, and 5. We also have man 1, man 2, man 3, man 4, man 5. So they clearly have names, but we're just going to label them by numbers. All right? All right, so these are the ones that we've chosen in this step. So we're completing steps, so we're going to multiply. So the next step is going to be to split them into pairs. And so our first pair, we'll start there. Our first pair, we have 5 women to choose from. So we'll say 5 choose 1. And we have 5 men to choose from. So just for illustrative purposes, I'm going to write below here, let's assume we chose woman 1 and man 3 in this one, in a particular count. That is certainly a possibility when we pick from the 5 women and the 5 men. Okay, so the second pair, we now have 4 women to choose from because we counted woman 1 and we picked man 3 in that count. So we have 4 to choose from both the men and women, and so on. So our third pair will be 3 choose 1, 3 choose 1. This is now our fourth pair. And now we have 2 women remaining, 2 men remaining, and our last pair is 1 choose 1 because we only have 1 woman remaining and 1 man remaining. Okay, so back to this illustrative purpose here. Let's say in this second case we chose woman 4, man 2. Okay? So that's certainly a possibility for the second pair. Well, what could have also happened if we are allowing for all 5 in this first pair, we could have chosen woman 4, man 2 from our original 5 and 5. Similarly, we could have then on the second one picked woman 1 and man 3 since they're still out there. And in fact, whatever we pick in this first choosing, we're going to overcount by all the permutations of those choosings. So this is where step 3 comes in, and we want to divide out the overcount. And the amount that we're overcounting is all the permutations of a particular pairing that we have ordered by this first, second, third, fourth, and last pairing. So we're going to divide out by 5 factorial. So to write our final solution, so it's clear, 10 choose 5, 12 choose 5. That's choosing the ones that will get paired. Then 5 squared times 4 squared times 3 squared times 2 squared. We're not going to write times 1 squared, although you could for completeness sake. And then our last step is to divide out the ordering of all of those pairs. So that is your answer to number 15. All right, let's move on to number 16. All right. A student has to sell 2 books from a collection of 6 math, 7 science, and 4 econ books. How many choices are possible if both books are to be of the same subject? Well, this is an or situation, so it's a choice and not a step, right? So when we complete steps, remember, we multiply along the line of steps. When we have choices, then we add them. We add the separate cases that could occur. So we could either get them from the math, in which case we would have 6 choose 2 ways we could do that, or, and so now that's a plus instead of the next step, we could choose 2 from the 7, or you could choose 2 from the 4. So calculating each of those and adding them up is the number of outcomes for both books to be on the same subject. Now, if the books are to be on different subjects, that's actually a hard thing to count by considering all the possible cases. So the way we're going to account this is we are going to look at what it's, we're going to subtract off what it's not, okay? So if the books are to be on different subjects, that is going to be meaning that they can't both be from the same subject. Well, the case that we counted up here is where the books are from the same subject. So if we look at all the possible ways we could get 2 books without any restrictions, and then take away the case where they are from the same subject, then we're left with the ways we can get 2 books where they aren't from the same subject. So the total number of ways we can get 2 books, well, we just throw them all into a big bin, and there are 17 here. So 17 choose 2 is all the ways we can grab 2 books from this pile. And if we subtract off our answer from part A, so answer from part A, this will be our answer for part B, right? So all the ways we could get 2 minus all the ways we get them from the same subject leaves behind the ways we can get to where they aren't the same subject. Okay? And if you want to count these to come up with a specific answer, 6 choose 2 is 15, 7 choose 2 is 21, 4 choose 2 is 6, and if you add those all up, you get 42. 17 choose 2, a quick calculation on your calculator will show you that that's 136, minus our answer from part 2, and what you're left with is 94. So 42 is your answer for A, and 94 is your answer to part B.